Good morning, sir. This is Ashwita from Computer Science and Engineering Department. I am here to give a presentation on diesel cycle working process and SI engine working. Outline of my presentation: Introduction to diesel cycle and SI engine working, diesel cycle working process, SI engine working, difference between diesel cycle and SI cycle, difference between Otto cycle and diesel cycle, advantages of diesel cycle and SI engine, applications of diesel cycle and SI engine, conclusion. Introduction to diesel cycle and SI engine working. The diesel cycle is a combustion process used in diesel engines. The SI spark ignition engine works on the principle of internal combustion. Both cycles involve the intake, compression, combustion, and exhaust processes. Diesel cycle working process. Intake. Air is drawn into the cylinder through the intake valve. Compression. The piston compresses the air to a high pressure and temperature. Combustion. Fuel is injected into the highly compressed air, igniting and creating a combustion process. This is the graph of diesel cycle working process between P and V and T and S. Expansion. The combustion gases expand, pushing the piston downwards. Power. The downward motion of the piston is harnessed as power to drive the crankshaft. Exhaust. The exhaust valve opens and the combustion gases are expelled from the cylinder. SI engine working. Intake. Air fuel mixture is drawn into the cylinder through the intake valve. Compression. The piston compresses the air fuel mixture to a high pressure and temperature. Combustion. A spark plug ignites the compressed air fuel mixture initiating combustion. Expansion. The combustion gases expand, pushing the piston downwards. Power. The downward motion of the piston is converted into rotational power by the crankshaft. Exhaust. The exhaust valve opens and the combustion gases are expelled from the cylinder. Differences between diesel cycle and SI engine. Fuel. Diesel engines use diesel fuel while SI engines use gasoline or petrol. Compression ratio. Diesel engines have higher compression ratios than SI engines. Ignition. Diesel engines rely on compression ignition whereas SI engines rely on spark ignition. Efficiency. Diesel engines are generally more fuel efficient than SI engines. Torque. Diesel engines produce high torque, making them suitable for heavy duty applications. Emissions. SI engines tend to produce more emissions compared to diesel engines. Difference between Otto cycle and diesel cycle. He, Otto cycle. Heat is addition in system at constant volume, whereas in diesel cycle, heat is addition in system at constant pressure. In Otto cycle, compression ratio varies from 6 to 10, whereas in diesel cycle, 14 to 22. In Otto cycle, high efficiency at the compression ratio, whereas in diesel cycle, low efficiency at same compression ratio. In Otto cycle, petrol engine work on Otto cycle. Diesel engine is work on diesel cycle. In Otto cycle, spark plug required, whereas in fuel cycle, fuel injector required. In Otto cycle, air fuel mixture inserted from inlet valve, whereas in diesel cycle, only air is inserted from inlet valve. In Otto cycle, after generating spark, combustion takes place, whereas in diesel cycle, combustion takes place due to hot air and fuel received from fuel injector. In compression stroke, air fuel is compressed. In compression stroke, only air is compressed. In Otto cycle, fuel is inserted during the suction stroke, whereas in diesel cycle, end of compression stroke takes place. In Otto cycle, there is no need of high pressure and temperature because spark stacks and the combustion. Whereas in diesel cycle, high pressure and temperature is required. It has low compression ratio, it has high compression ratio. Advantages of diesel cycle is are fuel efficiency, power output, durability. Fuel efficiency. Diesel engines offer higher fuel efficiency due to higher compression ratios. Power output. Diesel engines produce more power and torque, making them suitable for heavy loads. Durability. Diesel engines are known for their robustness and longevity. Advantages of SI engine. Smooth operation. SI engines offer smooth operation due to the use of gasoline or petrol. Lower initial cost. SI engines tend to be cheaper to manufacture and purchase. Emission control. SI engines can be equipped with advanced emission control systems. Applications of diesel cycle. Automobiles. Diesel engines are commonly used in commercial vehicles, trucks, and heavy machinery. Generators. Diesel engines are widely used in power generators due to their efficiency and durability. Marine industry. Diesel engines power ships, boats, and other marine vessels. Applications of SI engine. Automobiles. Engines are used in most passenger cars and motorcycles. Small engines. SI engines are used in lawn mowers, chainsaws, and other small equipment. Aviation. SI engines power small aircraft and recreational flying missions. Conclusion. The diesel cycle and SI engine working processes have distinct characteristics and applications. Diesel engines are known for their efficiency, power, and durability. Spark ignition engines offer smoother operation, lower initial cost, and can be equipped with advanced emission control systems. Thank you, sir. This is presented by Ashwita from Computer Science and Engineering Department.